Hey there, Mr. Thompson here with a video maths lesson talking about finding the equation for a line, and maybe you're given a graph of a line or you're given a few coordinates for a line, but we'll talk about how to write the equation for that line. And in order to do so, you need two things, okay? You are going to need the gradient of that line. So you'll need to find the gradient one way or the other, also known as slope. So the steepness, how steep or flat or whatever the line goes up or down as it goes across. Okay, and you will also need the coordinates for one or more points. Okay, at least 1 point on the line. So you need the coordinates, and you might need to look at a graph and find that. You might be given those coordinates, whatever the case may be. Okay, now. First, let's talk about how we find the gradient, and then we'll figure the rest out by looking at an example. All right. So, generally, whether you're given the graph of a line or you're given the coordinates for some points, you'll need to take those and find the gradient. Now, if you're just looking at a graph, you can go from one point to the next. Okay, how much does it go up, and how much does it go over? Put the rise over run, which of course is what gradient is, and that will give you the gradient, whether it's a fraction or a whole number or whatever. Sometimes it's a little more complex, and you need to, it's maybe not so straightforward in terms of just how much does it go up or how much does it go over. It can be a little trickier. So what we can do is think about, well, the rise is the change in the height, right? The change in the vertical, the y direction, and the run is the change in the x direction, the horizontal. Okay, so whenever we are dealing with change or difference, that is subtraction. So in order to find the gradient, we can do one of the y coordinates subtracted from the other. So y1 minus y2, and then divide that by the difference in the two x coordinates. Okay, so we've got a change in the y, the vertical change, over the horizontal change, the change in the x. All right. Let's look at how that works in an example. Okay. So for this example, and you'll see lots of problems like this probably, is that you will see the equation for the line. You'll be asked to find the equation for the line through a couple of points like this. So we have -2, 5, and then 1, -1. We need to find the line through that. And maybe it's that you looked at a graph and there was two points plotted and you figured out the coordinates, whatever, that's fine. These ones wouldn't be too hard. If you had those graphed, you could see the rise and the run. But I'm going to go through the process of how this will work no matter what, even if it's really tricky decimals or whatever the case may be. Maybe it's a really big scale and it's just not something you're keen to graph or something like that. We can find the gradient by doing that formula we saw on the previous page, y2 minus y1 over x2 minus x1. So we'll take these 2 points, the 2, 5, and we see that we have x coordinates and y coordinates for each of them, x and y. And we'll say, let's say the first one, the -2, 5, that's going to be 0.1. And then the 1, -1 is going to be 0.2. So we label the x and the y, x1, y1 over here, and then x2, y2 over there. All right, and we can take those numbers and plug them into this equation. So -1 we've said is y2, and then we're going to subtract y1, which was 5, right? Now, I'll take a minute here. I chose one point to be 0.1 and the other to be 0.2. It doesn't matter which one's which, okay? You could go in either direction, all right? You can swap those as long as it's consistent, as long as the x and y match in terms of being 0.1 and 0.2, or, x1 and y1, x2, y2, as long as you swap everything and you don't have x1 with y2 or something like that, all right? So we've put in the -1 minus 5 because those are our y coordinates, and then underneath on the denominator of this funky fraction, we're going to put 1 take away -2 because those are our x coordinates, okay? Well, -1 take away 5, you've got a negative number and you're taking more away, so it's going further negative, and so that's going to be -6. And then we have 1 take away -2, 1 minus -2. Subtracting a negative is the same as adding, so it's 1 plus 2, which is 3. So we have negative 6 over 3, which of course is negative 2. So that is the gradient of the line that goes through these 2 points. Okay? So step 1 was find the gradient. Now we need to use those coordinates. Remember, the 2 things we need are the gradient, which we found, and now we're going to use those coordinates. So we're going to plug the coordinates into our gradient intercept form of the equation for a line, right? Which of course is y equals mx plus c, or you might see y equals mx plus b or whatever, okay? And we're going to plug the coordinates for one of our points into that equation. I have chosen this second set of points that I've circled in red here that I'm going to plug into this equation. And I've chosen them for a particular reason, and that is because there is a 1. Okay? Ones are always easy to do calculations with. Not that much easier than 2 or 5, but they are a little bit easier. 1 is just a nice, easy number to do any adding or subtracting or multiplying with. So that's why I've chosen that one. Okay, so I know my gradient is negative 2, so I'm replacing the m with my negative 2 that I have for my gradient. I know the x-coordinate that I'm using is a 1, so I've plugged that in where this x was. And you notice I'm using the brackets or the parentheses every single number. It just keeps things really clear. And I know that that's going to be equal to negative 1, because that was the y-coordinate, and we don't know what this c value, or you might see a b value or whatever there, the variable. We don't know that that's the whole thing that we're trying to find. Like it says here, solve for c, right? So we just put plus c, and we're going to simplify to find out what that c value is. Okay, well, negative 2 times 1 is just negative 2, so we kind of just cross off the 1, which, like I said, nice and easy to deal with there. And so we've got negative 1 equals negative 2 plus c. So we're going to add positive 2, or in other words, subtract negative 2 from both sides. Easier just to add 2, to isolate c and get it all by itself. So negative 1 plus 2 is, of course, positive 1, so c equals 1, right? That's our c value. That's our y-intercept, okay? Now we can take that and write it into the equation for the line. We get y equals negative 2 because that was the gradient, and then plus 1 because that is the y-intercept, the c value or b value, whichever one you're using, for that line. Now, there is one more step, and I'm going to have to scoot over here a little bit to get out of the way. Circled my answer, which is great, but there's one more step. The last step is to check your answer, okay? And the easiest way to do that is if you have another set of coordinates like this, negative 2, 5, then you can plug those into the equation you've got and make sure that those points work, that those satisfy the equation and make the equation work. So we plug those in, we take our equation, and we put 5 equals negative 2 times, negative 2 times negative 2 plus 1. So we've replaced the y with a 5 this time, because that's the y-coordinate from this point up here. And we've replaced the x with 2 because that, negative 2, because that is our x-coordinate for that point. Now and I've put a question mark here because we're checking, we're asking ourselves, is this equal? We're not sort of assuming it's equal. We're going to say, is this equal? And then we'll say yes or no. And if it is, then we're in good shape. So negative 2 times negative 2 is positive 4. And then, of course, 4 plus 1 is 5. So that confirms that we've done our work correctly. We've got the right equation. And this answer that I've circled here before is indeed the right answer. And the great thing about checking your work like this is you don't need the back of the book or a teacher to tell you it's correct. You can be very confident that you've done your work correctly if another point from the original problem works in your equation. So highly recommended you do that on a test or quiz or any time. Thanks for watching. That's it for now, and I will talk to you next time.